Picture a cold English night in 1785. In the garden behind 19 New King Street, Bath, a German-born musician stands beside a telescope unlike any the world has ever seen. It's massive, 40 feet long, with a mirror 4 feet wide, built with his own hands. William Herschel adjusts the eyepiece and peers into the darkness. Around him, the air is still. Above him, thousands of stars hang like dust, suspended in black water. He isn't just looking, he's counting. 1 star, 2 stars, 20, 100. He moves the telescope slightly, sweeps across another patch of sky, and counts again. His sister Caroline sits nearby with a notebook, recording every number he calls out. They've been doing this for hours. They'll do it again tomorrow night, and the night after that. Most astronomers of his time pointed their telescopes at planets, at comets, at the moon. Herschel is doing something stranger. He's trying to see the shape of everything. He's trying to draw a map of the galaxy itself, a place so vast that light takes 100,000 years to cross it, and he's doing it the only way he can, 1 star at a time. For all of human history, the night sky had been a mystery wrapped in mythology. The pale band of light stretching across the darkness, the Milky Way, was a river, a path, a spill of divine milk. But what was it, really? By the 18th century, a few thinkers had begun to suspect the truth. Perhaps those glowing clouds weren't mist or fire. Perhaps they were stars, countless stars, so distant and so densely packed that they blurred together into light. Galileo's telescope had hinted at this, but no one knew for certain. And even if the Milky Way was made of stars, even bigger questions loomed. What shape did it have? How large was it? Where did we sit within it? Were we at the center of creation, or just one point among billions? These weren't just astronomical questions, they were existential ones. To map the galaxy was to understand our place in the universe, and in 1785, no one had ever tried. Before Herschel, the cosmos was still a small place in the human imagination. Most believed the universe consisted of the solar system and a sphere of fixed stars beyond it. Beautiful, yes, but fundamentally simple. The stars were thought to be roughly the same distance from Earth, like lanterns hung on the inside of a great dome. Some philosophers speculated further. Immanuel Kant proposed that the Milky Way might be a vast disk of stars rotating in space. Thomas Wright imagined it as a shell or a ring, but these were ideas, not maps. No one had measured anything. To do so seemed impossible. Stars were points of light. You couldn't touch them. You couldn't travel to them. How could you possibly determine their distances, their arrangement, their number? The tools didn't exist. The mathematics was incomplete. Even the concept felt beyond reach. And yet, William Herschel, a musician turned astronomer, a man who had taught himself telescope making and mathematics, believed it could be done, not perfectly, but well enough to see for the first time what kind of structure we lived inside. Herschel's method was bold and beautifully simple. He couldn't measure the distance to every star, but he could count them, and he could assume that, on average, stars were spread relatively evenly through space. So if one region of the sky contained more visible stars than another, it likely meant that region extended farther into space, that you were looking down a longer corridor of stars. It was like standing in a forest and trying to understand its shape by counting trees in different directions. Night after night, year after year, Herschel conducted what he called star gauges. He divided the sky into hundreds of small sections. In each one he counted every star he could see through his telescope. Sometimes a section held 50 stars, sometimes 500, sometimes thousands. Caroline recorded it all. She was more than an assistant. She was his partner, his co-observer, a scientist in her own right. While William swept the skies, Caroline organized the data, cross-referenced catalogs, and discovered comets of her own. The work was exhausting. On winter nights, the ink froze in Caroline's pen. William's breath clouded the mirrors. But slowly, section by section, a picture began to emerge. When Herschel finally assembled his counts into a diagram, he saw something extraordinary. The Milky Way wasn't a sphere, it wasn't a ring, it was a flattened disk, a lens-shaped structure, thick in the middle and thin at the edges. and the sun sat somewhere inside it, not at the center, but not at the edge either. He had done it. For the first time in history, someone had sketched the architecture of the galaxy. It wasn't perfect. He couldn't account for dust clouds that blocked distant stars, and he underestimated the galaxy's true size by a factor of 10. But it was real. It was based on observation. It was science. And it was breathtaking. Herschel's map didn't just describe the Milky Way. It redefined what a galaxy was. Before him, the word nebula covered everything fuzzy in the sky: clouds, clusters, distant lights. Herschel showed that many of these objects were structured, that they had shapes, depths, populations. He also revealed the shocking scale of space. If the Milky Way was a disk containing billions of stars, and if some of the faint nebulae he observed were even more distant, then the universe was almost incomprehensibly large. Humanity wasn't just small, we were a single grain of sand on a beach that stretched beyond imagination. The scientific community reacted slowly. Some celebrated Herschel's work, others doubted it. The technology to verify his conclusions didn't exist yet, but his influence spread. His telescopes became models for future instruments. His methods inspired generations of surveyors and cartographers of the sky. By the 20th century, astronomers like Harlow Shapley and Edwin Hubble would refine and correct Herschel's map, revealing that the Milky Way was even larger than he'd imagined, and that it was just one galaxy among billions. But they built on his foundation. Herschel had proven that the galaxy could be mapped. He'd shown that human beings, armed with patience and mathematics, could reach across light years and sketch the invisible. Today, we map the universe with satellites, spectrographs, and supercomputers. The European Space Agency's Gaia mission has measured the positions of nearly 2 billion stars with stunning precision. We've created three-dimensional maps of the Milky Way's spiral arms, its central bulge, its halo of ancient stars. But the principle behind all of it traces back to Herschel: observe patiently, count carefully, and trust that patterns in the data reveal structure in the cosmos. His telescopes too live on. The giant reflectors he built pioneered techniques still used in modern astronomy. Every time a space telescope captures light from a distant galaxy, it's using mirror designs descended from the ones Herschel polished by hand in his workshop. And perhaps most importantly, Herschel proved something that transcends astronomy: that the universe is knowable, that even the largest questions can be approached with simple tools, clear thinking, and relentless curiosity. He didn't have computers, he didn't have photography, he had his eyes, his mind, and his sister by his side, and he drew the galaxy.